In this lesson, we will graph a quadratic function that is in vertex form. So we have talked about quadratic functions before. The quadratic function has ax squared plus bx plus c. We've solved this with factoring. We've solved this using the quadratic formula. Now we want to know what the graph of the function looks like. So we know that if we graph the function, that it's going to make a parabola, which is a U-shape. So as you can see, I have a U-shape that's facing up and a U-shape that's upside down. It can be either one of those things. When it is written in vertex form, we have f of x equals a and then x minus h quantity squared plus k. So what we're going to do is we're going to talk about how to get from here to here in the next lesson. In this lesson, we're going to talk about when it's already in this form, what is our graph going to look like, or how can we easily graph it. So the first thing you want to look for is the vertex, and the vertex of the function is the lowest point if it's open upward, or the very highest point if it's opening downward. That point is going to be h comma k, which I can find very easily within my vertex form of my function. Now what I'm looking for here, notice this is a minus h, so if it was minus 2, h would be positive 2, but the sign on the outside will be the same. That's going to give me this point. The axis of symmetry is the line that is vertical that goes through the x value of the vertex. So it's not pictured here, but we tend to draw a dotted line through that vertex, and that's the axis of symmetry. And notice it's the line, so it's a whole equation of x equals whatever that h value is. So let's say this was at positive 1, that line would be x equals 1. If the parabola opens upward, a is greater than 0, so a would be that value on the outside. So this would be an a is greater than 0 situation, and if a is less than 0, then my parabola points downward. So that's what we're going to call that the leading coefficient. If the leading coefficient is positive, it's up. If it's negative, it's down. Let's take a look at how easy it is to graph using vertex form. So the first thing I'm going to look for is the vertex. So I'm going to look, this is minus 2. Remember, the inside of that is going to be the opposite sign. So my vertex is going to be positive 2 and then negative 9. So we use the sign on the outside, we use the opposite sign on the inside. So 2 comma negative 9 is right here, and that's my vertex. Now that's either the very highest point or the very lowest point, and the way that I know that is by looking at the a value. In this case, that is 1, so positive means therefore it's going to be opening upward. Other things that we can do to help us, and of course I'm going to go ahead and do my axis of symmetry, which is the line x equals 2, which means over here I've got that dotted line at x equals 2. And what this is going to help me do, and this will make more sense once I get a few more points on here, is that's a line where I could fold it directly in half and it would be the same on both sides. So the advantage here is if I find a point on the right side of the axis of symmetry, I can reflect it over to the left side of the axis of symmetry. So let's see, by finding the vertex, which we found, the axis of symmetry, which we found, the x and y intercepts, and then 2 other points. So to find the intercepts, remember I'm going to plug 0 in for x, and that would give me 0 minus 2 quantity squared minus 9. 0 minus 2 is negative 2. Square it, that makes it 4. 4 minus 9 is negative 5. So at 0 on the x, I get negative 5 on the y. That's right here. Now here's where I'm going to use the axis of symmetry. Notice my point of 0, negative 5 is 2 units away from the axis of symmetry. So I'm going to reflect it 2 units to the opposite side of the axis of symmetry. And then I'm going to find the x-intercepts. So I'm going to say 0 equals x minus 2 quantity squared minus 9. Easiest way here is to add that 9 to each side, which gives me the square root of everything, which would be plus or minus 3 equals x minus 2. To find those 2 points, I would say x minus 2 equals 3, and x minus 2 equals negative 3. If I add 2, I get x equals 5. If I add 2, I get x equals negative 1. So at 5 and at negative 1. And on this one, I'm not even going to find 2 other points because I found 5 points. And in general, that's how many I like to have, is 5 points. So I'm just going to, wow, try to connect the dots better than that, hopefully for you. And that's the general shape of my vertex. So if I wanted to be more exact, I could find more points, but 5 is sort of the minimum there. Here's another for us to try together. Again, first thing I'm going to do is find the axis of symmetry, which is inside is positive 2. So I know that means the vertex is at negative 2, comma, negative 1. So negative 2, negative 1. The axis of symmetry is always x equals, and then whatever that x value is, so negative 2, which is this dotted line here. That's going to help me reflect some points later. The x and y intercepts, so if I plug in 0, I get negative x plus, 0 plus 2 squared minus 1. 0 plus 2 is 2. 2 squared is 4, but this negative on the outside makes it negative 4. Minus 1, which gives me negative 5. So 0, negative 5. I think that was the one last time too. Use that axis of symmetry to reflect it 2 places. Notice this one, the parabola is pointing down, and we can also check it with this sign. Since there's a negative on the outside, it will be pointing down. If I try to find, and I can tell already what the graph is going to look like, but let's say I really want to find those x-intercepts, and I said 0 equals negative x plus 2 squared minus 1. I would add the 1 to each side. I've got this negative here, so I would divide each side by negative 1. And then I would take the square root of each side. And of course on this side I'm taking the square root of a negative, which makes it imaginary, which means there's no x-intercepts. So I found that y-intercept here at 5, or sorry, at negative 5, but there are no x-intercepts, which makes sense because we know this is going to point down. This one, since I only have 3 points, I will go ahead and find another point. It's very easy to find another point. Just pick a value and plug it in. So I'm going to choose positive 1. So I'm going to find f of 1, which means negative 1 plus 2 quantity squared minus 1. 1 plus 2 is 3. 3 squared is 9. So that's negative 9 minus 1, which is negative 10. That gave me the point 1 comma negative 10. Which is down here. And remember it said 2 other points, so instead of doing any more work, I'm going to say this is 1, 2, 3 units away from the axis of symmetry. So I'm just going to reflect it to the other side. 1, 2, 3 units over here. And now I have a pretty good idea of what my parabola is going to look like. Here's one for you to try on your own. So press pause, graph the function, then press play to check your work. Again, I would start with my vertex. So my vertex here would be negative 2, negative 4. The axis of symmetry would be x equals negative 2. I'm always going to start there. Negative 2, negative 4. And then draw that dotted line at negative 2. I'm not sure in Alex if they'll make you draw that axis of symmetry, but it's a good idea to know where it is. To find the intercepts, I would find f of 0. And we know, of course, that this one's going to be pointing up because it's positive, so this one should have a couple of x-intercepts and a y-intercept. This would be finding the y-intercept, so plug in 0, and I get 0 plus 2 quantity squared minus 4, which 0 plus 2 is 2, 2 squared is 4, so that's 4 minus 4, or 0, which means 0, 0 is my intercept. I'm going to reflect that 2 units to the opposite side. This one I'm not even going to worry about the x-intercepts because I already found it, because the y-intercept and the x-intercept happen to be the same this time. So I will go ahead and plug in another value. Let's say I plug in 2. So let's find f of 2, which would be 2 plus 2 squared minus 4. 2 plus 2 is 4. 4 squared is 16. Minus 4 would give me 12. So that is a little bit off of my graph, so maybe I should have chosen 1 instead. But I can still go ahead and reflect it. That's 1, 2, 3, 4 units away. So 1, 2, 3, 4 units to the other side. And then do a better job than me of connecting the dots. And that's what your graph should look like.